Good day and welcome. I'm Mr. Simons. This lesson we're doing some revision of Venn diagrams, knowledge that you should know from prior. So, a Venn diagram, these diagrams are usually used to show a relationship between a series of things or events. Here we have example of a Venn diagram. There we said let T represent tennis players and C represent cricket players. Right? So from this, our sample space, meaning the whole people that were involved in the relationship testing, 55 plus 70 plus 15 plus 10, so all in all 150 people partook. Right? Now my number of tennis players, 55 plus 70, my whole circle for T is 125. So all in all I had 125 tennis players. My number of cricket players, 70 plus 15, which gives me 85. My number of players that play tennis and cricket, the part where the two circles intersect, 70. Right, we said probability that you play tennis, that would be 55 plus 75 divided by 150. So 125 over 150, which simplifies to 5 over 6. Must always simplify a fraction. Probability you play cricket would be 70 plus 18, which gives me 85 over 150. Simplifies to 17 over 30. Probability T intersection C, or also PT and C, would equal 70 over 150 or 7 over 15. Probability you're not playing tennis and not cricket, right? Also notated as P, not T, and not C, would be 10 out of 150. So this 10 here, not worried with tennis or cricket, which then becomes 1 over 15 if we simplify. So that's a basic Venn diagram. It's the information we get from it, so I can get sample space. Circle of T shows me all the tennis players. The whole circle of C shows me all the cricket players. Whatever's outside the circles is those people that's not interested in tennis or cricket. Right? And they're basic probability questions. Now, they say this A intersection B is also A and B. That in short means the elements belong to both A and B. So on a two Venn diagrams where they intersect, that's the part A and B. No? Then we have A union B, A or B, which basically is all of A, all of B, minus the part where they intersect. That would be A union B, or A or B. Right, so that's just basic notation you must get used to. We don't need to write A and B, we can write A intersection B. We don't need to write A or B, we can write A union B. So make sure you know both of them. No? Now, not A, there, A prime, not as not A, represents all the elements that don't belong to A. So if we look at what we call complementary events, probability of A plus the probability not A must always equal 1 or 100%. So I can say in short the probability of not A, if I take probability of A across, would become 1 minus probability A. Not A is also known as the complement of A, right, which is that black part there is not A. So according to addition rule, one that we'll be using a lot, probability A or B will equal probability A plus probability B minus probability A and B. So these are just some basics that we're refreshing. Hope you enjoy. In the next lessons we'll go more in detail. God bless. Bye.